this company is bringing the best of the maritime industry into the VTOL industry. With this, they are really shaping the form of what's going to be the very first flying cars. And this is really exciting. Let me introduce CycloTech. Hello again, everybody. Welcome to another episode of Builder Nation. Today, we are joined by Markus Steinke, CDO at CycloTech. Markus, welcome. Thank you very much for being here with us today. Could you please introduce yourself a little bit?
Yeah, thank you, and welcome to everybody here. Yeah, make individual air mobility as normal as driving a car. Huh? This is what is on our agenda, and where we will be bringing one unique new capability to the aviation and automotive industry, and this is the CycloRotor. So an aviation propulsion system which actually can do 360-degree thrust vectoring, so in all directions. So, but I tell you more about it. Me, myself, I have been 30 years in aerospace with the classical guys of helicopters and fixed-wing, Eurocopter, Airbus, and so on. And then, then I moved into this incredible startup, CycloTech, which is actually based in the middle between the Oktoberfest and the Mozart opera. So we are in Austria, in Linz, between Munich and Vienna. Very nice location at the Danube River in front of the Alps. So good place to be, and even better place to make innovation and good business for the future.
It definitely does seem like a really cool place to make this innovation. Actually, back in the day, approximately a month or 2 months ago, we had another guest who was also more or less in the same area. They developed like a drone to fly through mountains and Alps, and it's. I mean, I can see it's sort of a hotspot for aviation and for unmanned aircrafts, right? For UAVs. So thank you very much for being here with us today. You already mentioned what you do, right? Which is this propulsion system that has a 360-degree thrust angles, basically. Now, to me, that idea, the very first thing that comes to mind is this sort of futuristic, kind of cartoonish cars, right, from sci-fi movies that have like the thrusters, they go up, and then the thrusters move, so they go forward and they move, right? This is, again, a sci-fi perspective, but could you please give us a real overview of the core technology behind the CycloRotors?
So it's actually much simpler and is already applied in water since many decades. So there is a physical phenomenon which the maritime, so the ship industry is using since long time, which is called the Voigt-Schneider propeller. Mm-hmm. And there it is applied to boats which need a lot of maneuverability and power, like the tugboats in the harbors, where they need to move the big ships. So maneuverability and power, or applied to big ships for stabilization in higher sea states, when big ships are, connected to oil platforms for charging and decharging to stabilize the big boats. So it's not so much sci-fi as already really on Earth, physics on Earth, and already available in water. And we apply the same principle now to the air. So you must imagine a CycloRotor is something, and I say the word, but it's wrong. But take your washing machine drum. Imagine you're from the size also, mm-hmm. First of all. Your washing machine drum, it's a drum, it's round like a drum. And inside this drum, you have movable wings. So spread out around from the center, there are wings, and each of those wings, let's take the number of 5, is doing a pitching motion back and forth.
Okay.
Each of those blades is doing this. And this full motion back and forth is during one rotation of the drum. So there are the individual blades who do this motion, and then the whole drum is spinning very fast with 3,000 revolutions per minute.
Okay.
So you have a double motion, overlaid motion of the internal fins which are moving. By the way, it is a little bit like dolphin fins, because how is a dolphin moving forward? So by this motion, so it is doing and that is what the blades are doing inside this drum. And when you turn it, it creates an interesting flow field in the middle of the drum. And because you have those fins inside, you can where you put the maximum of the pitch, where this is in the drum, you can direct the thrust into this direction. So you have the ability, to have a very quick change of magnitude and direction of the thrust with such a system. And as I said, it's rotating with high speeds.
Yeah.
So it is also rotating. That's why we also say cyclorotor to the whole
system
part of it. And so there is this aerodynamical mechanical part to it, and then there is how is all this driven, which is an electric motor. And this is so particularly interesting because we are now in this 21st century, we see the birth of a new aviation industry. And the new aviation industry is the electrically driven short-range air mobility industry. We know the air taxis projects, we know the air shuttles, some other individual drone applications, but you must imagine we are seeing a new industry being born, which is answering to the new requests of mankind. So the old one is still there. So the old one is medium and long range flight with fuel and with CO2 emission. And this is still there. But we are seeing a new element now, short range, sustainable, electrically driven aviation. And this new industry is working with the old tools of last century. So they are working with propellers and with rotors and combination of those things. Because all of them, they want to do this vertical takeoff and landing, then they stay in the air, and then they try to go from vertical to transition into the horizontal flight. And at the end of the journey, they break in the air, more or less, come to stop in the air and go down again. So this is the movement when everybody tries to solve, and they try to solve it with rotors pushing them up and propellers pushing them forwards, or they take tilting rotors, and so they make very complex combinations of rotors and propellers and so on in order to solve this equation. Now, if you have a cyclorotor, where you can put your thrust vector in any direction, you can very simply move up, lean over your thrust, and continue into the other direction, still creating lift, by the way. You can reverse the thrust, so you can brake, you can come to a hold, and then you can descend. So where others have a lot of complexity in combining different means. With cycle rotors, you just have a simple solution for this movement which is done. And then there comes other aspects, because this is just the movement up and forward. But imagine all those air taxis also which we are built today, flying around, and they will experience quite some wind and some gust, especially in cities and around skyscrapers and wherever. You always have local gusts. You don't know what is coming next. So it's not like at a big airport where you know, here is my landing strip, this is the wind direction, I have a weather forecast, and the guys from the tower tell me exactly the air conditions. But if you are doing that in the new electrical short range transport, this will be not available. So you yourself need to be much more reactive with your vehicle to compensate for gusts. So now you never know from which direction the gust comes. So if you have a 360-degree system, you can use this reactivity in all directions in order to compensate for...
Right, to keep it steady.
To keep it stable. And then you might have not thought about it, but here, and I take my mouse here, but typically if it's helicopters or the VTOLs, when they want to accelerate, they lean forward to get, and then they lean forward and fly like this, and then stop. And if they want to turn, they bank, because they need to the thrust vector. They need to lean the thrust vector, so they are leaning the whole vehicle.
Right.
With a cyclorotor, if you want to lean the thrust vector, you don't need to turn the vehicle. So you can, anytime if you want, you can keep the vehicle horizontal, because the vectoring is done with the system. So you keep a stable platform. What means in terms of passenger comfort is on a different level. You can control the environment of the passenger in how you can keep the cabin. You can compensate for gusts, so you reach a total different level of passenger comfort. And speaking about gusts, then we are also speaking here about safety. So operational safety is if you finally fly anywhere, because in our vision, we will see that this century will bring the individual or personal air mobility to the people. Last century, it's worthwhile looking back. It was bringing, I can also fly. So I as a passenger, I can fly from the US to Australia, from Asia to Europe. Something which at the beginning of last century was not normal, and it was, and it's nowadays it has become almost normal and affordable, which was not the case at the beginning of aviation.
Right. So of traditional aviation,
of traditional aviation, and even if you go back to the moment last century, because today we are looking for a new industry for this century. Last century, if you go back, there was also this emerging new aviation. And there was also the moment when there was one invention of a propulsion system which changed the course of the century in aviation. And this was the invention of the jet engine. Because before there were propeller and piston engine driving the propellers.
Right.
So the first 20, 30 years of aviation were propeller and piston. And then there came one unique new system, which was bringing one capability not before existing, and this was speed. So this invention brought the speed, and with the speed, it brought also altitude, and in different steps over time, when it was perfectionized, it became also the most affordable. So the cheapest way to fly today
Right.
is with those high turbofan jet engines, which came later into the play, and which are very normal today. But there was also the birth of a new industry building on a new propulsion system. And here we see again, and this one is, so it's not the long range US, Australia, it is 100 kilometers, 60 miles, 70 miles, but using the airspace now, because the resource, because there is the issue of the ground resource, which is now very limited. So we know in our big cities, but not also in big cities, also everywhere else, ground resource is limited, and actually will become even more limited if you think going into the future. You could say global warming, sea level rising, but water will somehow rise, and land footprint will reduce even more. So also today we want to make a lot of efforts in what is the land use? Do we want to build on this land a lot of streets and infrastructure, or do we want to use the land for agriculture and so and for trees?
Right.
So,
instead
there is this fundamental
roads.
question. Exactly. Instead of building huge networks of roads for everybody to go from left and right. If you have the ability to build roads, because it might be, if you are living, for example, close to, or if you're there in Sweden, in Stockholm area, where you have thousands of islands where people live on, where they need to get onto the boat and get somewhere to a road, and then they go from the road, they go over bridges, and then a ferry, they go to work. Then this is also one part of the reality. Also in the Philippines, so if you look how so we cannot say that people always have roads available in order to move. And in the future, it might be even less. But what is the point? The point here, and I think that's why we see this all, we see that by using the airspace, there is a resource which has not been really used so far for mankind. And whereas the Earth is really limited, if you go into the airspace, you can work on various layers. So you are not only replicating the surface of the Earth, you increase, actually, the further you go, the more surface you are getting, and you can double, triple, fourfold. So there is a big resource available in order to make people move. In combination with sustainability, this is one of the reasons, and for sure there is always a business case behind, but why do we see more than 800 designs for electrical short-range mobility? So if you look up in the Vertical Flight Society database, you find more than 800 designs all over the world, North and South America, so Europe, Asia, Australia, everywhere. Everybody is working on trying to solve this thing, using the old technology. So we are now saying, okay, here we bring you something new, exactly what you will need in the future. And this is our cyclorotor. And that is also where we are aiming at we are aiming at the second wave of those electrical flying vehicles. So we are not currently looking or what is Joby doing, and Archer and Volocopter and EHang, and everybody is out there. And they are the first wave. So they are very good that they come, and they are preparing the questions and the airspace and airspace management. People are getting used to, this is really happening. So next year, when
sort of laying the field, right? Sort of laying the field.
Exactly. They are really preparing the first step into the future, and that will be also with piloted services, which is good. So there will be more fixed network from a scheduled network with a pilot on board. So people slowly, it's great for the introduction of this, of those new electrical flying tools. And next year on the Olympic Games, we will see flying taxis all over Paris. This is clear and decided, and you can actually buy a ticket already today. So if you wanted to buy something like that, is available. So they have.
I did not know that.
The route network is established, and for example, you have one nice landing spot in the middle of Paris, on a floating boat on the river Seine in the middle. So all this is happening, and there are the other projects all around the world which become reality. So really starting out from next year onward, we see this new reality really reaching the ground. So now back to CycloTech and our cyclorotors. Our timing is the second wave of vehicles. So it's not where you have piloted, scheduled networks and scheduled services. It is when the next step comes, where you have more point-to-point flying. With your individual decision. So in scale, you can take out from your garden, or you take off from just in front of your house.
From your garage, and all the way to.
Yeah, exactly. Like, and then you get up and fly where you.
This actually triggers one specific question for me, right? I mean, you've given so much insight. Thank you very much for that. But this triggers one question, right? Which is in the part of, as you mentioned, anybody could, in theory, just own one of these aircrafts and put it in the garage and just fly it out, right? What is the impact on training that pilots are gonna need? Is it the same sort of as a helicopter, or is it more oriented like a car, or is it going to be a totally new sort of a preparation that is going to be required to fly one aircraft with cyclorotors?
So in that, so if you go on further on in time, the key question is, or the answer is, it will be autonomous. So the end game is autonomous operation. So the vehicle itself is intelligent enough to run the flight control system. You are punching in where you want to go. The system is getting the slot in the airspace. Let me also say, some people think it will be a chaotic airspace. Everything is flying from left to right. It will be not chaotic. You can, maybe as a help to think is, if you just would take today's road network, but you imagine that there are a layer above and another layer above.
Like levels.
Yeah, like levels. So it does not mean that flying is chaotic movement through the air. You can also organize the airspace and you can move in this airspace in organized, so in a safe manner. That's what we want to say here. So you integrate yourself in some air traffic, and then so it will not need piloting skills. It is, and actually, we must say that today, if you go to an autonomous car, is really more difficult to build and operate than autonomous air car, because in the air car you just go up
and straight line, right?
Yeah, and there are no obstacles. So for sure there are the other things which are flying, but this is organized, and it's like in today's, every airplane today which we fly up there has the anti-collision systems on board. If they come too close, they talk to each other. They have the avoidance pattern, so that they're not, when they meet, that they don't do the same thing and crash.
Right.
So they communicate and say, okay, and they fly like that. So this is already, there's nothing new. It is just that it will be also applied to the smaller vehicles. But autonomous flying, I mean, I think your people know, but the pilot on board of an airplane today is working 5 minutes when he's starting.
In takeoff and landing only.
Yeah, and then 5 minutes he's landing, and in case of emergency and so on. But otherwise, it is the autopilot which is flying.
Right.
Your Boeing, your Airbus, your Embraer thing across the Atlantic, and then it's supervised, and everybody can step in. That's what the pilots are for. But the real flying is done by the vehicle.
Yeah, that is true. I never actually, considered that. I do know that the main thing of this is precisely takeoff and landing for aircrafts. I would assume that it's going to be similar in VTOLs, as you mentioned, which it's actually pretty cool. But then it also addresses another question, right? As you mentioned, really looking into the future. You already mentioned that maybe one of the challenges is going to have to be sort of to determine these levels above the roadmap that we currently have or whatnot. What is also your vision on noise pollution? Because helicopters and airplanes are loud. So
here I have good news for you, because with our cyclorotors, so the measurements we have been doing. So if you have cyclorotor and have 100-meter distance, which would be typical flyover, something or even less would be. Then you are at 59 dBA. So 59 is roughly the sound level we are currently having when talking. So the two of us, we are currently at 59 dB. Then comes the interesting point, because with the cyclorotor thrust vectoring, you could also do in a limited way noise vectoring, because you know that that noise is the disturbed air, the waves which are there emitted. So you have a possibility more in order to control noise or use to optimize the overall flying profile. So that is an interesting phenomenon in itself. And then there is more the philosophical question. If you imagine you go by road from one point of the city to the other, then you pull with you along the 25 miles, you pull your noise on ground level through all of the roads, to pull it through the whole city, you pull your noise emission. So your car is constantly making noise, and you are disturbing along 25 miles, you are disturbing all the people left and right. So if you fly, is you disturb at the beginning because you take off, you go higher, then you are almost not hearable, and then you disturb again when you land, because there's typically this the most powerful situation and noisy is when land, because you give there a lot of power.
Right.
So the overall noise footprint is smaller. So if you but those are all this is not typical cyclorotors. No? This is all the arguments for why is this flying taxi world coming. So why are those electrical guys coming? This is all what everybody out there is doing, and having those new principles, how you can imagine mobility. And cyclorotors is one specific aspect in helping to optimize this new way of moving.
Right, and actually that is a very cool way to see it. But now I have to move into something that I've been looking for forward, right? Which is to actually see it in action. Now, just as context for anybody watching here, Markus, you shared with us 3 different sources, so I can share with you a couple images, right? And also a video, and specifically the video is the one that I want to see right now, because it is a real live test that you actually posted like 5 or 6 days ago, if I'm not wrong, of a demo, right? Which is actually, it's pretty cool. It's pretty sweet. So what I'm gonna do right now is to share this over the stream. It's gonna be over the stream. If you want to, Markus, for all of us to see it sort of at the same time, you can just open it in your own tab and we try to watch it at the same time. It lasts for around a minute, for what I could see. I mean, I watched it entirely before starting. It's super cool. And talk us through it. Talk us through what are the steps that are going through once we see it. Talk us through.
Because what we see here is a technology demonstrator. This, what we see, is not supposed to be like that, a flying car of the future. So we have later images for you how we imagine the flying car. But here you see a technology where you have 4 of those cyclorotors attached. And you see how this propulsion system is really, how this is working,
right,
and how it is driving the air vehicle.
Yes, I totally understand. We're gonna see the render that you made about like a real live, like finished product in a minute. But first, I would like to see the video. We have it ready over here. Everybody's looking at it on the screen. If you want to pull it on your own, it's totally fine, Markus. We just want to see this, right? I just want to see it. So I'm gonna go ahead and start it playing right now. I know that at the beginning it is more or less of an explanation of how you built it. But let's jump right into it.
Yeah, let's go.
All right, so watching it over
Hello,
here.
My name is Rami Kanan.
Is the sound with it coming through?
It does. It does have sound. Yes, it does have sound, and everybody's gonna be able to hear it right now. For example, we have Rami Kanan on the screen.
Engineer and test pilot here at CycloTech.
Yeah, flight engineer. Yeah. Let's. I think it's self-explanatory.
After months of indoor preparation and bench testing,
we come to the end.
That sounds pretty good to me. Yes, I mean
we are now excited to fly outdoor for the first time.
Yeah, at the beginning he does mention that
equipped with the latest flight control system
outdoors.
And all the knowledge.
Yeah, exactly. Because 2 years ago we were doing the indoor flying already. So flying indoor we did since quite some time. But here it was that also there now we are operating according to the real airspace rules.
Right.
So you need to get authorization from, in the US it would be the FAA, in Europe is EASA. So you need to get an authorization from the aviation safety agencies in order to operate the vehicle and the rotors with it. So here, first of all, is that people see that the thing is really
during
working.
indoor testing and flying.
This thing is really flying. So it's not only somewhere on a test bench or some nice words. So those things are really flying. And the other message here is it is under the rules of the aviation authorities. That I think is where it is important. Here we show, in this video, we show simple flying.
Hello, my name is...
Because later we will demonstrate the unique elements of those cyclorotors, because you can do things which you cannot do with other vehicles. For example, you can just stand in the air like this. You can have some pirouettes and so on. So there is something, because you have this system, it gives you more degree of freedom, and also you can build totally new aircrafts. You can build a new breed of aircrafts because you have this new thrust vectoring ability on board.
And that's actually one question that I wanted to ask you. I mean, right now your focus is on building just these thrust vectors, right? These propulsion systems, the cyclorotors. Are there plans in the future for you to build entirely your own flying car, basically, which is a great way to say it?
It's not our plan. So it's not our plan would be to be the Rolls-Royce, the Pratt & Whitney of the future for electrical flights. So a propulsion system provider which can serve many different aircraft manufacturers. So not only our own. So this is the basic idea. And then you can also use those cyclorotors not only as a main propulsion system, as we saw, for example, in the video. You could use it also as auxiliary system. For example, we have questions from cargo balloon operators who want to have a very precise maneuvering capability to bring big pieces of constructions or windmill blades. When the windmills are established and when they hang the windmill blade in 150-meter height to the hub of the... and they are saying, we want to have this maneuverability. Here you are back to the tugboats in water. We want to have this power and maneuverability for the superpositioning or the fine-tuning precision aerial work. So the cyclorotors can be used in many ways.
Yeah, I mean, it is precisely, I mean, what I saw, for example, over here is that the cyclorotors are sort of placed where the wheels would typically go, right? Which is sides, forward and backward. It was the second question that I was going to ask you. Like, I mean, seeing this technology, is it, for example, in the future plans to make maybe a few smaller cyclorotors to add even more sides of even more thrusters into a vehicle, or is that something that would depend on whoever is building the car itself, and they would just implement?
Here you have so there are different ways forward, and maybe it's the time to show the picture of an air vehicle. The picture. Because
sounds good.
Here you see that this is using 6 cyclorotors actually.
So it's incredible to see it fly. So, all right, we have the render right here. You mentioned we have 6. Yes.
You have 4 which are out there more like the wheels. 2 in the front, 2 in the back, and then you have 2 in the center of the vehicle. And you see on the center axis, and with the one in the center axis, you can actually nicely create the sideward movements. You're flying to the side, You can create the yaw movements of the vehicle, and they are also the reserve. If you, for example, you have a power failure of one of the rotors, the center ones can still do lift. So they are also
Okay.
so they go to the side anyway, the angle, but they can go up and down. So you can, with those ones, you can control. This is constellation. You can control all movements and still keep the cabin flat. You don't need to bank or tilt or anything. And that would be one of a design, so a 6-rotor design. But it could also be that somebody wants to have more. He says, I want smaller ones. I do something with 8 or 10. This is absolutely possible, and there is no limitation to it. It's really to the overall concept.
I see.
Yeah, just on the picture itself, you see the dimension. So I would say, if you take your car and want to make it fly, you need 50% more, 50% more in length,
okay,
and in width and in height.
All right.
So this is the dimension. For example, this one there you on the picture was 6 meter, 6.5 meter, and then 3 meter 30 wide. So typically, your car plus 50% in all direction gives you the flying car. This is what you need to bring there in order that you can see that it's still in our normal scope. So it would be 2 parking spaces easily somewhere at home and so on. So it is, and this is so important because cyclorotors are compact. They are small. If you look at today's air taxis, which have a lot of rotors everywhere distributed, and then some of them, they have wings. And so here with cyclorotors, you don't need wings, you don't need other control surfaces. You can do all. You can do lift, thrust, forward thrust, and control all with the cyclorotors. And this makes it then very compact and usable in normal human dimensions. And it's then also using less airspace. So, which is important. Again, if more and more are really out there, then if they are really out there, then it's better they are small, because then the airspace can take more than if you have always the big ones. They need safety distances and so on. So this is another fundamental advantage of cyclorotors. It's the small size of it, where everything is encapsulated in one tool.
Right.
All this together brings this unique combination. And let me speak a little bit about timing here, because we spoke that since, I think, that's 15, almost 20 years, there is this new electrical aviation move ongoing. Which is coming to fruition from next year on. We see them really in operation. So roughly 20 years later. We, with our cyclorotors, aim at a market window in 10 years from now. So we will.
And so far, how long are you in R&D? Like, how much time have you developed this?
So we have already developed. So the company itself, it was founded in 2004. Where the principle was established to go with cyclorotors. At the time, it was still with combustion engine and more the heavy metal approach. So the first 12 years were more on trial and error. And then came a little rupture and a new approach, which was more using the latest art technology, so electrical motors, all the scientific approach, the CFD calculations, all the latest materials, and so on.
And this was around 2016, right?
Exactly. 2016, there was then the rebranding into what is now CycloTech, also with a new team on board. And since then, I think there was this systematic from the idea to over technology to product, because that is what it should be at the end. It should really go as a product into the market. And we are here now at the final step.
Wow.
The final step is, final means still long, but the final step is doing in aviation, going through all what will be a certified product. So there will be quite a certification effort to be done over the years to come. And our clear statement is we don't want to be too early because the environment is not mature. And we don't want to be too late. And we want to be too late because there will be a big boost coming. If you see what the automotive industry is investing and doing in electrical flying vehicles, I don't know if you are aware that from Daimler, from Stellantis, from Toyota, from Suzuki, the big Chinese ones, all active, all in different forms, Porsche, all are in different, sometimes they have their own projects, sometimes they have huge financing of the eVTOL industry, but they are all learning and positioning themselves for the next element. The next element is flying cars. So, then it is not taking away anything from helicopters or from our normal planes. The next move is eating into the car industry. So it will be there where the individual air mobility is coming. And so this is already happening as well. So automotive guys are positioning themselves in different ways and forms across the world. And back to my point. So we see a good point to be in the market in 10 years from now. So to have there the product well established and in the marketplace, because that is where here is a little information on the European side with the European Safety Organization. There are also the plans to have autonomous flights possible. So the regulator has a roadmap over time where he also sees autonomous operations, and that also will be in place. So our product is unique, bringing exactly what is needed for the next move of mobility. We are not in a rush. We have no time to lose, and certainly no time to waste, and no money to waste. But that is never the case.
But nobody has money to waste.
But it is about the systematic way forward to have a certified product available for the industry. The industry can be coming from eVTOL, it can come from aviation, but also the automotive. So there will be a big surge when this kicks off, and our children will be flying with their flying cars to work one day. So that's, I mean, it will be like that.
It's really hard to imagine it in 10 years, but I mean, what you mentioned, right? That you plan to launch within the following 10 years.
In 10 years it starts, and then it will grow.
Yes.
And then it will really, and not everywhere in the world. So there will be some pockets where it's starting, then other ones will follow. And then finally, it will be a new standard of moving around will be established. And I hope in good terms when I saying this, then I mean, because here we are on electric aviation, I spoke about the change of the world, because we will see more economy, we see less ground, we see more also everything. We will see more floating cities. So not everything will be on land. So so then how do you move in floating cities? So there will be a lot coming this century. I mean, if you go back, let's take what our people did last century. So when they invented the car engine, they had no computers, they had nothing, they didn't have composites or something, and 80 years later they landed on the moon. So from steam train to landing on the moon, 80 years. So now, then imagine our innovation power, and I'm not speaking about ChatGPT and so on now, but imagine what we have in hand today and what is all coming and we can do. And then what makes sense to do. And here's the point. We need to what we can do, and which makes it really added value to mankind. That is what we have to bring together. And that is one of our drivers here. And let me add with a little, because I have people, but then imagine then this is all flying and that could be noisy. And if I want to look at the sky, I want to see blue sky. I don't want to see
flying cars,
flying cars. Okay, then typically I answer, we as mankind have the chance now to continue to live as caterpillars. So we are creeping on the ground and continue to creep, glued to the surface. All what we do is glued to the surface. And then even with worms digging holes inside. So we continue to live in like a caterpillar, or we need now to go through the metamorphosis and change and live like butterflies, because electrical cars are like butterflies. So the fundamental question is, yes, it is a change and things will change, but you can remain a caterpillar, or you can become a butterfly.
That's a very nice way to think.
Are different, and I think we are at the point where we can become, if we want to become, butterfly people. So because currently we are worms, so we are caterpillars creeping around every time. And for those who are standing in the big traffic jams, they are more or less more than creeping there. So,
I mean, this is a very nice way of thinking about technology sort of evolution. So thank you for that idea. I'm actually going to use it, this analogy. I believe it is, I mean, we're running out of time over here, although I could keep on talking about this forever. It's super interesting. But with this little message that you shared with us, which is about this evolution, I have one final question for you, Markus. And this is because of you have an amazing experience and an amazing journey. You know, I mean, you were in Airbus, you're an engineer, you have like a master's, and you're leading the development of this new tech at CycloTech. My question to you is, do you have any advice for any young people out there who might be starting their own career, their own path, maybe in engineering, maybe in aviation, maybe in entrepreneurship, perhaps? Do you have any advice for them looking forward to this very technological future?
Yeah, I think they should not take today's world as a norm. And sometimes I speak to people in Europe, and then they think Europe somehow is a norm, and noise levels are the norm like this. And so they think this is a standard. And then I often say, I don't have it here now, but if you have fever, you get your thermometer, you take your thermometer, put it under. That was the classical way. The classical way was, or you put it there under the, and then you look 36 something or 7, I don't know what.
Yeah.
And you know that, and I was still using this for a long time. Whereas the whole of Africa, the whole continent, was using already, the infrared measurement devices. So this little pistol thing. So the whole of the African continent was in technology more advanced than I was here sitting in my Western something, thinking. The reason was at the time they had to fight Ebola. And every child who was coming in school in Africa, every morning had to be temperature checked, and then if they were sorted out. So everywhere was already a higher technology than where you are. So you have to, if you are young, you need to be careful with what is your reference. Is your reference or your perceived reference really that what is good or standard, or should it be like that? You should be open for really other ways of thinking, moving standards, and I mean, it is really true that if you aim for, and I have been more than 30 years in business, if you really want to achieve something, you can do it, and things are changing, and you can do new products and new services and new stuff. It's really happening, and you can watch it, and then later you are a user of it, or you make this stuff, and then or you make it. And I think you should be on the making side, and it's very rewarding for yourself because you have created something which is lasting, which made a difference. And looking back, things which are normal today have not been there before. And it's absolutely possible. I mean, that is the message. It is possible. Be careful with your references or what you think should be normal. And then really go for it. You can make it change. And that is, for sure, it's also effort and takes some time once in a while. It is there, but it will be there, and it's great. It's great to be part of all of this. And then there are all the others. You are not alone. A lot of other people have intelligent new things. Try to combine, try to synthesize, to communicate, and then you will find a lot of new solutions. Which we all need, and then try to good solutions which really help the world, the mankind at large. Then it's even easier because it's easier for yourself. It's easier to explain to your neighbor. And maybe some of you are young, but there comes the time when you have children, and children will ask you, what are you doing? Why are you doing this? And so if you do something which really makes sense, then if you have the chance, do it. What makes sense? And because there can be always other drivers. We all know about making the most of the money and so on, but and it can be combined. And then in 10 years from now, have a look in the new shops, because there will be those air cars waiting for you, which you can take. So today, so we have our ICE engine cars, so internal combustion engine cars. We have our electric cars now. So in 10 years, we have electric flying cars. So watch out for it, and then
be a part of it, as you mentioned. That is the perfect way to finish it. Thank you very much for these, Markus, for this really cool advice of just looking around and just not closing yourself up to other technology. Appreciate it a lot. Thank you for sharing your experience, your thoughts, that video, those images. Now, where can we find you on CycloTech? Do you have any social media handles on your website?
Yes, we have a website. We are on Twitter. We are on LinkedIn. We are X. It's gone now, Instagram. We are not yet. But yes, you can find us via social media. You should by CycloTech.
Sounds good. Also, I recommend watching the YouTube channel. It's full of really cool info.
Yeah, you're right.
That video is really cool. So thank you very much for sharing that. Remember, everybody else, that you can find more information, interesting articles, and interviews directly on our website, buildernation.io. We're gonna love to hear from you. Again, thank you very much for being part of this community. Thank you again, Markus, for joining us. This was an incredible talk. Appreciate it a lot. And just, well, go on. Have a great day.
Thank you for having me, and keep going. The world needs builders. Yes.
The world needs builders. Thank you very much.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic 3-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.